Good morning and welcome to Managerial Accounting once again. We are at the end of April, very near the end of the semester, of course. We will be starting chapter 27 today. So the chapter 26 problem, since we finished chapter 26 last Thursday, the chapter 26 problem should be submitted for grading by the end of the day today. I did schedule a drop-in review session. The only time I had available was 8 o'clock tomorrow morning. So if you do need assistance with that chapter 26 problem or anything else, that would be the time to sign up. Go into Starfish. In the courses area, you should see a link for the review session right by our class. So please sign up if you want to go over anything, including that chapter 26 problem tomorrow morning. Because we're starting chapter 27 today, of course, the pre-quiz should be submitted by the end of the day as well. And our third exam was due on Sunday. I know most of you submitted that. If you did not submit your exam, you should have received a Starfish alert from me yesterday reminding you that that was outstanding and asking you to touch base with me with a plan for how to get caught up. So questions, anybody? We'll cover chapter 27 this week, chapter 28 next week. Our last class for new material then will be next Thursday, May 5th. Day 30 of class is Tuesday, May 10th, but that will not be an actual class time. That will serve as our final kind of drop-in review session. And then the last exam, which is covering just these final three chapters, 26, 27, and 28, will be due no later than Friday, May 13th. That is also the last day that you can submit any new work. That's the final day of the semester. And grades are due on Monday. So I need to have everything in. Anything that's not submitted as of the end of the day on the 13th will be counted as a 0. So make sure that if there's anything that you've been working on and kind of hanging on to, thinking you'd get back to it and maybe improve your grade, make sure you get those submitted so that your grades can be carried over. I did yesterday go through and update all the grades from CNOW into the Blackboard gradebook. If you see anything that looks funky, if you see anything that you think is missing, that you did submit in Cengage but is not showing up in the Blackboard gradebook, just let me know. I did not go through every single assignment since January to make sure that, you know, if you had a late submission, I will do that at the end of the semester, of course, but it's very time consuming to try to maybe pick up one assignment. So if you see something specific in your grade book that you think doesn't look right, compare what's there to what you see in CNOW and then send me an email and I'll be happy to take a look myself. So the grade that you see in Blackboard right now reflects all of the work, or virtually all of the work that has been submitted up to this point in CNOW. Keep in mind that does not include zeros for things that are outstanding from earlier chapters. If you do not go back and turn those in, then they will become zeros in the grade book, which obviously will bring down your grade. So I don't want anyone to be misled looking at your grade now and saying, oh, cool, I've got a B+, without paying attention to the fact that you might have 10 assignments that you just never did, and that's not going to help your grade. So right now there are no zeros in for missing assignments. Because we do have a couple people who, for a variety of reasons, may not have taken the exam yet, I'm not going to take individual questions on the exam, but you should be able to review your exam, excuse me, in CNOW. And obviously, if you do have any questions, I would be happy to go over those with you. I just can't do them during class on the recording. So let me know if you do have questions. Please also do not assume that other people in the class have taken the exam. It may not be true. That you may be talking with someone who has not yet taken the exam. And so you should keep that in mind and not share information about the exam with other people. Before we start the new chapter then, any questions on chapter 26 that we covered last week? Capital investment analysis. Okay. Our new chapter then, I'm going to show you in the reference materials folder. There are a couple videos, and I would like you to watch both of those on your own. It absolutely makes no sense for me to try to show them to you over Zoom and then to record them onto our recording for today's class. But they are both very relevant. You can see one's about 5 minutes, the other's about 24 minutes long. I do want you to watch them, and I would consider that part of today's class. So I may even end class early today to allow you to, in this regular class time, to watch those on your own. Like I said, it just doesn't make sense in this format, especially to try to show a video. So they're both here. They're both about Toyota, and both very relevant to our topic in this chapter on lean manufacturing. Toyota is kind of the pioneer of lean manufacturing. And if you haven't ever seen anything about their production system, you might find it amazing. Okay. If there aren't any questions, I'm just going to go over here and start our discussion for today. Excuse me, on lean manufacturing and activity analysis. So I don't really have anything to add to those learning objectives for the chapter. I think they speak for themselves. We're going to talk about what lean manufacturing is. I want you to watch those two videos as an example of the early pioneers in lean manufacturing. And then we'll be looking at what activity analysis is and how can we use that to improve the organization. So really the focus of lean manufacturing is on that continuous improvement, making sure we're not wasting any of the resources of the organization. That includes time, energy, as well as things like materials and those more concrete concepts. So the whole purpose or the whole goal, the driving force behind lean manufacturing or a lean enterprise is that we're producing goods at a high quality at a low cost, that we can be nimble and responsive to changes in the environment. We've talked about, it seems like it comes up in every chapter, the concept of pull-through production. And the idea of being a lean enterprise means you can react very quickly to changes in demand or changes in the manufacturing environment. You've probably heard the term just in time or JIT. Just in time, we tend to, if you don't really dive into it, we tend to think of just in time referring to inventory. That our raw materials show up at the back door of the facility just in time to get them onto the manufacturing floor. In other words, we are focusing part of our energies on reducing inventories. So starting in chapter 6 in financial accounting, we talked about the concept of inventory carrying costs. And we know it costs money to have materials sitting in our warehouse for a variety of reasons. One is the fact that we have to have the warehouse in the first place. So we aren't storing materials in advance of needing them. We don't need all that physical space. We don't need employees who are hired just to run the warehouse. We don't have to inventory all of those. We don't have to pay our suppliers for the inventory for the materials until we actually need them. And so it cuts down on our cycle time. It cuts down on our financing period or the cash gap, the operating cycle of the organization. But to just think about it in the concept of our raw materials arriving just as we need them ignores all of the other possible improvements related to lean manufacturing concepts. So we can use this idea of reducing waste and cutting down anything that's not value adding. We can apply that in so many more areas than just the raw materials coming into our facility. You can see here on the second bullet point, we can use these principles even in organizations that are not manufacturing. And believe it or not, we can apply lean principles when we talk about our accounting processes as well. So as we say, we want to cut down or eliminate waste, eliminate unnecessary work, that also can be applied in our accounting department. Unnecessary work could mean excess accounting entries, too many journal entries. So how do we combine and consolidate that? So we'll see that in this chapter as well. So you can see some examples here. I'm going to try to get this out of the way so we can see it in the classroom. So we can see some of the examples here of how lean manufacturing has helped to reduce waste in a variety of different areas, not just that inventory, but lead time. So from the time we receive the order until we're actually working on it and then shipping the product, how do we cut down on that? Setup time. So when we talk about lean manufacturing, we're not talking about having all the machines that look alike or do the same thing in one room, and then we have another room or another building that does some other process. But instead, we actually reconfigure the entire factory so that we reduce transportation time, so that we reduce the time to literally move the product from one machine to the next, reduce the time that it's sitting there idle. Because every minute that it's idle, it's costing us money. So I just mentioned the idea of production layout. Within lean manufacturing, we empower our employees to make more decisions, to if they see a quality defect, they are empowered to shut down the production process before we produce 100 defective units. We've got pull manufacturing here. I keep talking about that pull-through production process. Emphasis on zero defects. So again, every employee is empowered to review or check the quality of their own work, rather than my job is to stand at this machine and continue to produce parts, and then eventually the inspector is going to come around and inspect those parts. No, under lean manufacturing, I'm responsible for the quality of my own work. And if I see a problem, I'm empowered to stop that work process. The last one on this slide is a little bit, I would say Toyota has a bit of an advantage over some other companies because of the way that Japanese industry is organized. So lean manufacturing, again, pioneered by Toyota, emphasizes supply chain management. But in Japan, many of the industries are what we call vertically integrated. So Toyota, we think of Toyota, maybe they make cars, they make trucks, but they also might make the engines that go into the trucks, or they might own the company that makes the engines. They might own the company that makes the tires or the, I don't know, the brakes and the the steering wheels and the whatever else goes into cars. So it's much simpler to maintain. I don't mean to say it's easy, but it's much less complex than in the United States, when all the companies that make, or all the parts that go into the car are made essentially by that same company. That's what we mean by vertical integration. It's a little more challenging in the United States when the engines might be made by Cummins and the brakes might be made by a totally separate company, and then the tires are made by Goodyear or Firestone or whatever. That doesn't mean it's impossible, though. Part of that move toward lean manufacturing means that we are working with our suppliers, even if it's a separate company, that we still are kind of all on the same team, and that we are not seeing them as adversaries or someone that we're trying to make money and we're going to cut expenses at all costs. We need to make sure that we have those relationships with our suppliers, and that means every step in the supply chain. So we're one step in that supply chain between maybe the raw material suppliers and the customer, but we want to make sure that's a seamless transition as much as possible. And so all of these concepts that you see on this screen are advantages of lean manufacturing. Doesn't mean it's easy, but if we were to follow the lean manufacturing principles, we are going to find that we have less waste, more efficient processes, more able to adapt to changing work environments, and ultimately we produce a better product at a lower cost, and therefore improving our profitability, maybe improving our market share because we can sell at a lower cost. So, whoops. About that for some reason. I'm going to let you read this slide because I think it's an interesting analogy. We have already talked about in an earlier chapter that producing for inventory can help us to hide problems, and I think this is a really interesting analogy, but I'm not going to read it out loud to you, so I'll give you a moment to read that. And there's the visual. The first exercise in the set for chapter 27, I'm going to let you complete on your own because it is just a multiple choice question. So read the scenario, choose your best answer. So exercise 1, complete on your own. And our first exercise that we're going to do together is related to setup time. So when we talk about lead time or throughput time, I already mentioned we're starting, we're measuring from really when we get the order and we want to start production and until it's ready to be shipped. So lead time can include things like, we need to order the raw materials and the supplier requires has a 16-week backlog. And so we get the order, we contact our supplier and order the materials, and we're told, okay, 4 months from now, we'll get those raw materials to you and then you can start production. All of that contributes to inefficiency. And so when we think about lead times, I think this slide kind of implies it's from the time we start actually, we have the materials and we start production, but that really we should be considering every time consumption, every time consuming element from the time we want to start production, that is, we receive the order. But as we're looking at our internal lead time, and maybe that's the best way to think about it. So there's lead time, which may involve external delays, waiting for our suppliers to get product to us. That clearly, if you're following anything going on in the economy, this is clearly an issue right now with supply chain, lack of resources. And so that means additional delays once we get the order. And then we can look at that internal lead time from the time that we actually physically start working on the product until it's ready to ship. And so that includes time, hands-on time that we are doing actual production work, but also any lag time between those steps. And so I've already mentioned the idea of reconfiguring the layout of our plants so that maybe we have a production line. I'm just picturing it across the room. Maybe there are, like you see here, 3 different steps in the process. Well, the closer we can put those 3 steps together, the less lag time there is between each step. It may mean putting 3 machines next to each other in the facility. It definitely means having set up processes that are changeable. So we may, for one product, need 3 separate stations or work centers, as this slide calls them. And maybe for another product, we need to bring in a 4th workstation. So we want to make sure that our machinery, our work processes are changeable, adaptable. And again, the traditional approach is, well, this room is for cutting, and this room over here is for sanding, and then we've got a 3rd room or another building where they're going to do the finishing stuff. So lean manufacturing definitely wants to have a seamless or a continuity of the flow of the product through each one of those work centers, cutting down the non-value adding time in our production process. Should have just changed the slide before I said that. So value adding time, remember, and I'm not going to remember which chapter it was now, it might have even been way back in chapter 15 when we started the semester. I said at that time we were talking about cost behavior and whether a cost was a product or a period cost, whether it is fixed or variable. And I said one of the concepts as we classify costs that's the most challenging to think about is this value adding versus non-value adding, because it somewhat requires us to get in the mind of our customer to recognize what the customer thinks adds value. In this context, though, it's pretty clear. If a product is sitting half done in a bin of other half done products waiting to be transported to the next building so that it can then undergo the next step in the production process, that clearly doesn't add any value to the customer. So this is probably the exception rather than the rule about, how do we know if it adds value? How do we know if a customer is willing to pay more for that? Well, clearly a customer is not willing to pay more to have the product sit around unless you're talking about a product that needs to be aged. So, aging a fine wine or whatever. Cheese, some cheeses add value just by sitting around. So, but that's not what we're talking about here. Those
that kind of include like dry times for items too.
Yeah, so
Staying on chairs and whatnot.
yeah, but if you can speed up that process without damaging the product. So And I never know if you guys on Zoom can hear the question in the classroom was, would that include things like drying time? And yes, drying time, although essential, we don't want it, we want to be as efficient with that as we can. So one of the, a couple weeks ago, I brought that book, The Goal, in. I was talking about Eli Goldratt and the one of the concepts or one of the steps in that production process in that book is going through a specialized piece of equipment that was I don't know if it was a kiln or not. Can't remember, but it was some kind of a heat treating, drying kind of thing that one of the ways he improved, the manager in that book improved the process, was by recognizing that not all the product even had to go through that step. So that step was identified as the bottleneck in his operation, and he realized they were really making it unnecessarily complicated. So when we talk about things like drying time or aging time, yes, there is, that may be adding value, but letting it sit around, if it takes 1 hour to dry, and so we set it aside and let it sit there for 8 hours, we have 1 hour of adding value and 7 hours of sitting around, that non-value adding time. So the title of this chapter is Lean Manufacturing and Activity Analysis. And that question goes to the heart of activity analysis. Let's look at what we're doing with a critical eye to say, what we're doing, how much of this is essential, and how much of it is sitting around and waiting and not adding any value. And there's a fine line when you're talking about, we just painted it or we just stained it, and now we need to let it dry. If we don't let it dry long enough, then we could be damaging the product. But if we let it dry, if we leave it sitting longer than necessary, we're adding to that lead time and not adding to the value of the product. So you can see two specific examples here of what's considered non-value adding. Time that the product is sitting, waiting for whatever comes next, and time spent physically moving the product from one station or one process, one work center to the next. So both of those are going to be targets for reducing our lead time.
Wouldn't the time spent moving things kind of be considered necessary evil? Like, I know you want to reduce it as much as possible, but isn't there going to be some amount of time that you're going to have to do that?
There's probably going to be some, but some might mean here's one machine and here's the next machine. I finish it, I hand it to the person next to me, or I finish it and I step next, and start. I mean, that's obviously very negligible time versus the traditional manufacturing setup where, again, the scenario I'm describing, we have a building for cutting or a room for cutting and another room for sanding and then a third room for finishing. But wouldn't it make sense to just have someone cut, someone sand, someone finish, look, it's done. So I think in the exercise we're going to look at, it's going to be really clear how we can make some relatively minor changes to our setup and save a lot of that setup time. And part of it has to do with batch sizes. So before we get to the exercise, let me just give you an example. So I'm picturing me standing here at this machine, and this is how traditionally this might happen. I have a job to do at this machine, and I'm working with something little, so I have a box next to me for the finished pieces. And so I do my thing in the box, do my thing in the box, do my thing in the box. And maybe that happens 20 times. Maybe the box holds 20 items. And so someone comes to pick up the full box when I get to 20. But how long now has the first item I finished been sitting in that box waiting? The 20th one may not wait much at all because, you know, the runner person is here to take the box as soon as I put number 20 in there. And that seems efficient because the box didn't sit there full for very long. But 19 of the 20 items have now been sitting for quite a while. And if it takes 5 minutes per item, the first item's now been sitting in there for 95 minutes. The last one just went in, but the first one has 95 minutes of wait time now. If I do one at a time and hand it to the worker next to me or step to the next machine, depending on how well cross-trained I am and, you know, how many steps I'm responsible for. If I do step one and give it to the next person, and now that person does step two, we just took for that item 95 minutes out of the cycle time. Does that make sense?
Yeah.
It's something you don't think about because you think, well, yeah, but as soon as the box was full, it went to the next step.
But the first one was sitting in there for 19.
But if we-
times the amount of time it took to actually wait.
Right. So the last one took almost no time at all as far as the wait time. The first one takes a lot of time. And so if we can reduce batch sizes, then in maybe the batch sizes, the ultimate, maybe the perfect batch size is 1, then we cut out all of that excess wait time. But then we need to reduce our setup times because if I'm doing one at a time and then I have to, oh, now I'm going to make a different product and I have to change out all the dyes or, you know, whatever else goes on the machine, you know, that adds to the time as well. So having
The other thing too is if you're trying to increase the effectiveness and stuff, if you're working 2 machines, one of them is not being used while you're using the other.
Yeah, so there's a cost associated with idle time on each machine. Yeah. And so that's why the concept of activity analysis can be really helpful. We need to take all of that into account. It's not just, am I standing idle, but is the machine standing idle? Is the product sitting idle? Again, back to the goal, and I can't stress enough how interesting I think that book is, just the insights that you get from it that maybe you never thought about. That I was talking about the bottleneck that I think it was a furnace. And so they would load up the furnace with however many items would fit in there. And then it was like 4 hours that the machine took to run its cycle. Well, the person who was running that furnace would put the stuff in and then just kind of hang back for 4 hours, and he had nothing else to do until it finished and he could take the stuff out and move it on, and then he'd put the next batch in. So the idea of cross-training and efficient use of our employees means that, yeah, the person puts the stuff in the furnace and then has something else to do for the next 3.5 hours rather than standing waiting. You know, that his sole function was to load the furnace and unload the furnace. Not very efficient. So his idle time, we also want to reduce. Again, visually, because I know that some people see things better this way. So you can see as you look at the steps in this process, that most of these steps are not adding value to the product. Transporting the raw materials, having the raw materials sitting in the warehouse. Drilling them adds value. Now they're sitting, waiting for the next step. Then they're being transported. Then they're put in the box ready to be shipped. That boxing up is adding value, but most of the steps in this process are not adding any value, and yet we're asking the customer to pay for them. Let's go to our first exercise that we're going to do together. And that is, oops, go. All right, apparently, let me try, hopefully it'll just, okay. So I said we're doing exercise, you're going to do exercise 1 on your own, but let's take a look at exercise 2 and talk about reducing setup time. So you can see the only thing we need to do for this exercise is answer 3 what amount to multiple choice questions. But before we answer those questions, I want to talk about and think about, go through each one of these steps. Excuse me. Vernon Incorporated has analyzed the setup time on its computer-controlled lathe. This setup requires changing the type of fixture that holds a part. The average setup time has been 140 minutes, so 2 hours and 20 minutes, consisting of the following steps. So without giving you the times, let's just walk through that. So you need to change the part. You need to change the type of fixture that holds the part. So you turn off the machine, you remove the fixture. You go to the tool room with that fixture, and it takes you 15 minutes to get there, apparently. Then you record that you're returning that part, and you go back to the lathe, you clean it, then you go back to the tool room to get the new part you need. You have to sign that one out. Go back to the lathe, install it, turn the lathe back on. The lathe has now been off for over 2 hours. It's not been used. So you can imagine if you're following this process, that your inclination is going to be to do as many parts as you can using that fixture, because you know when you have to change the fixture, it's going to eat up 2 hours and 20 minutes of your time. You're definitely not going to want to change that fixture every 5 minutes, every part that you do. So the questions that we have to answer. A company plans to set up a machine to increase the productivity. The average setup time is 140 minutes. Do you think the management needs to minimize the setup time? In other words, is the 140 minutes reasonable, or should we be looking for an improvement in this process? Well, I think it's pretty clear if we're spending over 2 hours changing the part that holds the fixture, that yes, we could come up with an improvement to that. And why do we want to come up with an improvement to that? Because let's just read through these options. If we're saying yes, we can improve it, then I don't think the answer is going to be the setup time's not a concern, because otherwise we wouldn't need to improve it. The setup time should be considered because long setup time leads to increased economic cost of the setup. That's definitely true, so B is an option. The cost incurred for setup can be ignored as it is related to machinery. I'm not even sure why we think something can be ignored because it's part of an essential process. Long setup cost can be recovered as depreciation. Clearly, that's not true. And so our answer must be, the only one that makes sense is B. We should consider setup time, excuse me, because it increases our cost. It increases our waste, inefficiency. It's not adding value. Excuse me. So before we go on to the next question, as we look at these, how many steps is that? Like 9 separate steps. Can you just off the top of your head, looking at those steps, come up with some suggestions for how we might improve this?
First ones that I noticed were, it took 18 minutes to record the replacement, and it took another 12 minutes to record the withdrawal. That seems like a lot to, in
A lot
my
of
mind,
paperwork.
basically write something in a book and grab it.
Yeah, and I don't, maybe this would be more realistic if we put a decimal point in there and said 1.5 minutes instead of 15 minutes. So don't get too hung up on the exact number of minutes, but just the steps in the process. So does it make sense that we need to record the replacement of one and then separately, you know, an hour or whatever later, record the withdrawal of another one? So yeah, that's one possibility. What else? Anyone on Zoom have any ideas? Anything that you see there that you're thinking, why do they have to do that? I can think of a whole bunch of options looking at this. So you're all just gonna wait for me to come up with my ideas. It's okay. I'm always happy to share my ideas. So where is this tool room? If these are the fixtures for the lathe, why do we have to store them in a separate room? Why don't we
Separate room
have
that's
them?
15 minutes away.
That's 15 minutes away, yeah. So why don't we just have the tools with the machine? Doesn't that make sense? Why don't we just put the tools with the machine rather than having them 15 minutes away? My next question is, how many lathes do we have? And how many, and maybe we only have one, that's possible. How many, if we have more than one lathe, how many different fixtures are there? If we have 2 lathes and 2 fixtures, maybe we don't have to change the part at all. Maybe we just put the, fixture A on this lathe and fixture B on that lathe, and we just run the product that needs fixture A on this one and product that needs fixture B on this one. And then we don't have to change the setup at all. That's one of the approaches of that nimble setup I was talking about, that you have a dedicated line that produces product A, and then you have another line that produces product B. Is there really an advantage to having, well, this line can produce A and B? Yeah, sure it can, but do we need it to? And so doing that analysis, and I don't know, I mean, maybe they do only have one lathe, but at a minimum, we could put the fixtures with the machines that use those fixtures. And if they have to be, if they're in a tool room because they're under lock and key and they're protected, maybe we just have a lock and, lock box next to the lathe. But it's possible we don't need to do any of this at all.
The only thing that I can think of that would explain it is if you have enough lathes that having an individual set of tools for each lathe is cost prohibitive.
Mhm.
But
Yep.
that's about it. And even then, I mean, depending on your setup, you could have it shared among 2, 3 machines.
Right. So these are just some ideas of things that we can look for to make this more efficient. Maybe you take the part off, you clean the lathe, then you take the part to the room and change it out. Instead of making 2, if it had to be in a separate room, maybe 2 trips to that room is not necessary. Is it, can we take the part off, then clean it, take the part, get the new part, bring it back, put it right on? Did you have another thought, Drew?
Oh, no, it was 2 trips, that's right. Okay.
Yeah. Yeah, we had to go to the tool room 15, and the second time you go, it takes 20 minutes to get there. First time it only took 15 minutes.
Well,
Second time it took 20
yeah,
minutes.
it takes 15 to go, 20 to come back, 20 to go, 15 to come back. So over an hour just going to from the tool.
Yes. So maybe it's a nice day like it was yesterday, but clearly we don't want to be paying our employee to do that. So a company plans to set up a machine to increase the productivity. The average setup time is 140 minutes. Company wishes to control the setup time. Identify the statement that suits the given situation. Let's read through those and see if you can come up with which one might make sense. So I was looking to see if we had a choice that we could say like A and B or A and C. Sometimes those are options, but we have to pick just one, A, B, C, or D. What do you think? So activity analysis tells us that we don't want to eliminate the steps that are value adding, but we need to be able to accurately identify all of the time involved here, which is adding value and which is not. And that to me sounds like letter A. And if we can identify all of the steps or all of the time in this process that are not adding value, that's where we want to focus our attentions to reduce or ideally eliminate all of that non-value added time. And if we look at this process of these steps, what's actually adding value? Cleaning the lathe is kind of important. I don't think we'd want to eliminate that. Maybe we can make it faster than 20 minutes. I don't know. But what's definitely not adding value is going to the tool room and coming back and going back to the tool room and coming back. We just want to change the part. If we have to change it at all, we want to get it off, get the machine cleaned, and get the new part on as quickly as we can. And most of that is unnecessary. In particular, the travel time, 15 minutes. We have a total of 30 minutes for recording the return of one part and the receipt of another part. I don't know that that's adding any value at all. If each tool, each lathe in this case, has its own set of tools, we don't have to sign them out because it's right with the machine. And when we take one off, we put it in the box next to the machine. So there'd be no signing it out. So how much time would be required for a setup using our suggestion in B? Identify the wait time and non-value adding time with effective planning so that the setup time can be reduced. So what is it that we really think is important here? Let's go down the list. We kind of talked about them, but let me just put a mark by the ones we think are important. Turning off the machine and removing the fixture, that's kind of important. Cleaning it, and then putting the new fixture back on. All those other things that I did not just check are not adding any value at all. And really that's the transportation time, as I think I said. So what do we have? 15 plus 20, that's 35, plus another 5 minutes, that's 40 minutes. We just went from 140 minutes to 40 minutes of value adding time. Turn off the machine, remove the part, clean it, put the new part on. 40 minutes. And Cengage agrees with us. So what kind of obstacles do you face with this transition from the traditional approach to the lean manufacturing approach? Thinking in the context of this exercise, if you are the, let's say, consultant who comes in and does the activity analysis and looks, comes up with this list of 9 steps in the setup time, and you say, okay, but only 3 of these are important, what do you think you'd hear from the folks who are responsible for actually doing this? What do you think you'd hear? You all had a job before, right? What do you think your reaction would be if somebody came into your workplace and said, you know what, there's a better way to do this?
It's hard to accept that from somebody who hasn't actually done it.
Okay.
So personally, I'd want to look at like credentials and why they think.
Okay. So the human instinct is to kind of defend your territory. And so someone from the outside, in my example, someone from the outside comes in and says, here's the answer. This is going to save us so much time. Going to save you so much time because they're the outsider. The initial reaction is going to be, it's not going to work. No, it's not. I can't tell you, when I used to work in the real world outside of academia. I can't tell you how many times when I asked the question, why do you do it that way? I was told, well, because that's the way I was trained, or well, we've always done it that way. That's human nature, is to defend your territory and say, yeah, no, this is how we do it. We have to go to the tool room and get the tools because that's where the tools are. They're in the tool room. Without questioning, should they be in the tool room?
There could be workers that aren't happy with the location of the tool room that appreciate a change anyway.
Yeah.
I know I personally wouldn't want to be running back and forth for an hour.
Unless it's
Just
80
get
degrees
tools.
and you get to wander outside and go around the pond and maybe sit down and feed the ducks. And
I mean, if you know, have a pond. and some
I'm
grass
just-
to wander around
I'm
in.
just wondering why it takes
There's-
18 minutes.
There's not a whole lot of area on the dresser compound that I would want to wander in. So
But there is a holding pond there.
there
Yeah.
is.
Yeah.
You get a chance to get that.
So, so thinking back, we talked about this in the budgeting chapter. So knowing that you're going to face that resistance, if you come in, if you're the consultant and you come in and say, I know how to fix this, the first reaction is going to be, it's not broken. Leave it alone. It works just fine. We get the tool, we get the part changed. Stay out of it. How do you then get people on board with this kind of change? That we're going to relocate the machines and put them in order so that we do machine A, B, C, rather than this is the room that has machine A, and that's the room that has machine B, and machine C belongs over in the other building. How do you get people to get on board with that?
Depending on the situation, it might be harder or easier than you think. Because sometimes it seems like it's the middle management that likes to clog things of like, well, this is what we actually have to do, even though the people who are actually doing the process might be like, if I was told it takes on average 18 minutes to literally just record the replacement of the fixture,
Mhm.
I probably would start asking, why does it take 18 minutes to do just this one part?
So here's my answer. The easiest way to get people to do what you think is best is to get them to come to that realization on their own. To get, and again, back to that budgeting chapter, we talked about authoritarian or authoritative versus participative. So we want to get people's input. So you don't walk in and watch people and say, here's what you need to do. You walk in and say, what do you think would be most helpful? If the sky's the limit and we're willing to entertain any idea you throw out there, what do you think would work? Because then you're going to get their buy-in because it at least seems like it was their idea. You pose the question, they propose the solution, and you're willing to listen to it. I think that's probably the fastest way to get this done, is to get the people who are doing it to come up with it on their own. Because as soon as you start imposing changes on humans, the reaction is almost always going to be, no, that's not going to work. And then there's no incentive to try to make it work. That's my opinion. Okay. This exercise is going to get to that question that we were talking about a few minutes ago of batch size and how the batch size affects the lead time. Williams Optical Incorporated is considering a new lean product cell. The present manufacturing approach produces a product in 4 separate steps. The production batch size is 45 units. The process time for each step is as follows. The time required to move each batch between steps is 5 minutes. So let me just explain what's happening here. So we move the raw materials to process step 1 in 5 minutes. So the raw materials in the warehouse, we move all of the raw materials for all 45 units in the batch We move those to step 1. Then each of the 45 units takes 5 minutes to process. And it's that situation that I was kind of describing earlier, where I spend 5 minutes doing unit 1 and put it in the box. I do 5 minutes on unit 2, put it in the box. By the time I finish the 45th unit and the box is full, the first unit's been sitting there. Okay. The time to move units from between steps is 5 minutes. So once I finish the 45 units, someone picks up the box and takes it to step 2. That takes 5 minutes to get them there, and now step 2 starts. 8 minutes on 1, in the box. 8 minutes on 2, in the box. 8 minutes on 3, in the box. And then we take 5 more minutes and transfer them to step 3, 4 minutes each. 5 minutes to transfer to step 4, 3 minutes each. And then 5 minutes to move things to finished goods inventory. The new lean layout will allow the company to reduce the batch size from 45 units to 3 units. The time required to move each batch between steps and the inventory locations will be reduced to 2 minutes. So again, we're doing that setup where we're just kind of passing them from one step to the next. There's no longer taking it to the next building or the next room. So we're not actually, in this scenario, we're not actually decreasing any of the value adding time. It's still taking 5 minutes in step 1 and 8 minutes in step 2 and 4 minutes in step 3 and 3 minutes in step 4. What we are reducing then is all of that non-value adding time, the transfer time and the wait time between steps. Determine the value added, non-value added, and total lead times and the value added ratio. And when we get to that, I'll go back to the PowerPoint and show you the formula for that. Under the present and proposed production approaches. So again, it's really tempting to just say, okay, well, it takes 5 minutes in step 1, 8 minutes in step 2, that's 13, plus 4 is 17, plus 3, it's 20 minutes. It takes 20 minutes to make the part or the unit, 20 minutes. But is that really true? Under the present approach, let me just get my annotate up here. Under the present approach, it takes 5 minutes to get the product there, the raw materials there. Now we get to step 1. And it doesn't take, whoops, I need my calculator. Isn't that crazy? We get an hour into class before I need a calculator. I'm obviously spending too much time talking. It doesn't take just 5 minutes on step 1 because we're going to do 45 of them. So it's 45 times 5. That's 225 minutes. We finish the first part in 5 minutes, and then it's going to wait another 220 minutes before it gets moved to the next step. And it takes 5 minutes to get there. I should probably label these. Whoops. So this is transport time. This is step 1. Then we have some more transport time to get it to step 2. Step 2 doesn't just take 8 minutes, it's 8 minutes per part, but we're going to do 45 of them. That's 360 minutes in total for the batch in step 2. And the first unit we produced is waiting 352 minutes, sitting there in the bottom of the box, waiting to be transported to step 3. I'm going to go up here. So now we're at step 3, and it doesn't just take 4 minutes, it takes 4 minutes for each of 45 parts, a total of 180 minutes for step 3. Now we've got to transport it again. Oops, that's transport, sorry. And again, step 4 doesn't just take 3 minutes, it takes 3 minutes for each of 45 parts for a total of 135 minutes. And the first part's been waiting 132 minutes now. And then finally, we transport it to finished goods. So there's every step in the process. How much was the value adding time? 20 minutes. But how long does it take to do the batch? If I added that up correctly, oops. The total lead time in the present approach was 925 minutes. And of that 925 minutes, 20 minutes per part, 20 minutes was adding value to the part. And that means there were 905 minutes that were not adding value. And we'll come back to that value adding ratio. Is everyone okay with that? Do you agree with those numbers? You see how it's not just a matter of looking at the 5 + 8 + 4 + 3 and saying it takes 20 minutes, we're good. Okay, so what I want to do next is I'm actually going to just change my color and I'm going to write in the new numbers right next to the old numbers. So for transportation, we've reconfigured our facility and we now have things much more closely located. They're lined up in our production cell. And now instead of taking 5 minutes, each one of those steps is going to take only 2 minutes. So each one of the transportation steps has been reduced to just 2 minutes rather than 5. And now our batch size is going to be 3. And so rather than taking 225 minutes for step 1, it takes only 15. And for step 2, it takes 12.
No. Step 2 should be
Oh,
24,
whoops, yep. Step 2 should be 24, yeah. Okay, oh, I don't think I can do that without really goofing things up here. So I'm going to just X that out and put 24. There, sorry about that. Step 3 is 4 minutes. So for 3 of them, that's the 12 I must have looked at. And then step 4 is 3 minutes. So that's a total of 9. So how have we changed? I got 70 minutes. So the total time has, for one batch, has gone from 925 minutes down to 70 minutes. Same 20 minutes of value adding time. And now we're only wasting non-value adding time, 50 minutes. Is everybody okay with those numbers? Does it make sense?
And can you go over how one more time how you, can you go over how you got
Got which one?
both for the total lead time, how I came up with that?
For the present approach or the proposed approach?
Both.
Okay, yep. So the present approach is a batch size of 5 minutes. So those are the black numbers. The transportation between each step is 5 minutes. Each step takes the time that you see here, but that's the time for each item in the batch, and there are 45 units in the batch. So the rest of these numbers, like the 225 for step 1, is 5 minutes each for 45 units. That's the 225. And then for step 2, it's 8 minutes each for 45 minutes, 45 units, and that's the 360. And so on. So I added up to find the 925-minute total lead time. I added 5 plus 225 plus 5 plus 360. So all of the black numbers, which is the current approach of a batch size of 45 minutes where things are more spread out and it takes 5 minutes to transport between each step.
Yeah, that makes sense. So but still just go over how you, but still do the proposed approach too. Oh.
Yep. So the proposed approach takes our batch size from 45 to 3 units, and all of the transportation, rather than being 5 minutes, is 2 minutes because things are more closely located. We've set up a production line, basically. And so all of the 5s change to 2s, and all of the individual steps still take the same amount per unit as was given, but now it's just 3 units at a time. And so for step 1, it's 5 minutes per unit times 3 units. That's a total of 15. For step 2, 8 minutes per unit times 3, and that's the 24. And so on for step 3 and 4. And so when I added up the green numbers for the proposed approach, that totaled 70 minutes.
Yep, it makes sense.
Okay, good. So I'm going to clear my screen. I want to go back to the PowerPoint so I can show you the calculation for this value added ratio. And so here's the formula. You might want to make a note of that. The value added ratio is, as you can imagine, the ratio of the value added time to the total lead time. So for our first, for the present approach, it's going to be 20 minutes of value added time divided by 925 total lead time minutes. So for the present approach, 20 minutes of value adding time divided by 925, and it says to round percentages to 1 decimal place, so that would be 2.2. It's 2.16 or 2.2. And then you can do the same calculation. It's still 20 minutes of value added time, but we've cut down on the transportation time. We've cut down on the wait time, because we're only doing 3 parts at a time. So the first part's waiting a lot less time. So the goal here is a value added ratio of 100%. This is kind of the pie in the sky, in a perfect world scenario. The goal is 100%. We don't want to spend any time on non-value adding activities. But the approach is just continuous improvement. So to go from 2.2 to 28.6 is a huge improvement. We don't want to stop there. We don't want to say this is good enough. We still want to be pushing toward that 100% by constantly improving what we're doing. Any questions? For number 4, I'm going to ask you to complete this on your own. As you can see, it's reading what's given here and then answering a few questions or filling in the blanks. So you can do that on your own. And the same thing for number 5. So we have about 18 minutes left in class time. That's a little bit less time than you need to watch those 2 videos. But I'm going to pause class here for today, halfway through our exercises, and ask you to either now or sometime before our class on Thursday, watch both of these videos. It'll take you about less than a half hour to watch both of those. So please do that before Thursday. And if you have any questions, we can talk about them in class on Thursday. And we'll finish up the chapter. Before I stop the recording, any questions, comments, anything else you want to talk about? Okay, so don't forget, there is that optional review session tomorrow morning at 8 o'clock. Make sure you sign up in Starfish if you want to attend. If no one signed up, I will assume nobody is coming and I won't open the link. All right, stop the recording. I'll see you Thursday.